And welcome to Ladyada.
Hey, all you cool cats and kittens. I hope you're keeping cool, as I mentioned, on this sweltering hot July evenings that we're having. We stayed in because it was just so hot out, and we did a bunch of engineering. So I got some stuff to show off on the desk of Ladyada, and we've also got a very timely, great search for those of you who are dealing with part shortages. Don't forget, if you're trying to find an alternative or a part and you can't because of silicon shortage, drop us a link on Discord and maybe we'll cover it on a great search and help you find the part you need so you can get your stuff made, because that's what we're all about, making stuff.
Some logistic stuff. The reason we're late is we're hanging out with Helen from Carrot Supply.
Super cool.
And
drinks like a fish.
Yeah. And Helen will tweet up some photos from the Adafruit factory and more. She's our first guest from the world in the last 18 months.
Yeah.
And we really like Crowd Supply, so
it was so cool to see her, and we chat about things that we can do together and ways to promote more makers and engineers doing business.
Next up, thank you, G3 Holiday. The Ada box was epic. We tried really hard. It's harder and harder to do Ada box, so thank you for appreciating it, because a lot goes into it each time, and it's hard to get parts, it's hard to ship stuff, and that was a heavy lift, so thank you.
Yeah, I always think every box that goes out, I personally think they're really cool, and 99% of people think they're cool too. I get it, it's not for everybody, but that's what I think makes it so special. If it was just a box of kittens and ice cream, I think everyone would love it.
Well, it would be melted ice cream and a dead cat.
I guess so. All right.
Well, people would really not like that.
That's why we're doing electronics. Don't forget Wednesday unboxing.
Yeah, Wednesday's unboxing. Neil and Pedro on Wednesday are going to do show and tell. And also, since the title of this was Desk of Ladyada Hot Summer Sunday Stemmas, I would like to point out that Hot Girl Summer is a meme originating with rapper Megan Thee Stallion.
Yeah.
And it's about feeling confident in who you are, having fun, looking good while you're doing it. Often involves women posting selfies in summery swag and style using the caption, "I heard it's Hot Girl Summer." So I'm going to post up her site and a little bit about this, because I've seen a lot of people use, hot blah blah summer. And some people are like, look, you don't understand. That came from someone else. You should at least say where it came from. And no one ever does. But we will. But don't worry. Someone is still going to not like me about this.
Megan Thee Stallion is fucking awesome. I love her.
I'm just saying, you could be perfect nowadays. It doesn't matter. There's always going to be someone, but we'll always be... I'd rather be honest than perfect.
That's right.
So that's where I'm at right now. I posted this up. Yeah, some people are not even familiar with this meme, and that's good for you, because that means you're not going to get people attacking you.
It's not from this year. It's from last year.
When someone says hot girl summer or hot, So I saw someone.
You can have hot boy summer too.
So I saw someone in the 3D printing community say it's hot nozzle summer.
Yeah.
That's super cool. And then someone says, you're stealing this meme or whatever. So my opinion is, why not just put the credit for where it came from, and then everyone could be happy. But no one is ever happy.
Nobody's ever happy, and that's why it's a hot Stemma Sunday. So let's jump in and maybe let's actually start with the computer, because I'm trying to show off some stuff. This is a hot matrix summer. So people from the previous Ada boxes, remember I did the matrix portal, which was a SAMD51 plus ESP32 airlift, and so we got like the power of the SAMD51, the wireless / Wi-Fi Bluetooth of the ESP32 together on one board, plugged into the back of an RGB matrix to make an awesome RGB matrix display that's really easy to program. I think we did a really good job with that design. However, I cannot get SAMD51s. I can barely even get SAMD21s. SAMD51s, I'm getting like 60, 70, 80 week lead times, and so I thought, instead of just being sad, I don't want to be sad.
There's an author, a pretty prolific author that does electronics books, that emailed me, and they said, I am so screwed. And so usually that's when people email me, when they're at the very end of the room.
True.
And they're like, how can you fix my problem? And they were trying to figure out, their book requires a SAMD. And I'm just like, I'm just like, you can't do it. But I gave them an out. And so anyways, it's resolved, but...
Yeah, no, it's tough. So the previous design... So actually, you know what? Maybe I'll open up the previous design. So the previous design looked like this. I'll show this off. So it was, and let's do basic. Okay. So on the front, hold on. I have to turn on the T-Docu because it looks good. There you go. Whoops. Okay. So this, you can see here, here's the SAMD51 over here. And then up here is the ESP32, and then together, then this plugs into, there's a level shifter and plugs into a matrix on the back. But like I said, you cannot get SAMD51s right now. Although, interestingly, Espressif's doing a pretty good job of keeping their stuff in stock. I'm more confident that I'll get Espressif chips than I'll get SAMD51s. And luckily, we've just recently ported, in the last 6 months or so, we ported CircuitPython, and Arduino has a great port for the ESP32S2.
Not reported, but ported. You didn't report something.
I didn't say report, I said ported.
You ported, yeah.
Sorry.
It sounded like reported.
If I meant report, I meant we ported CircuitPython, and Arduino has a port also for ESP.
I report things, but as a company, Adafruit ports things. Look, I want to get it.
Sometimes we re-port things. Like if we need to redo
I would say re-implement a port because report, bad word.
Okay. Anyhow, so what I did is I actually ripped up everything and slapped down an ESP32S2, which is a lot longer than the ESP32, but it has, enough PSRAM, which I really like, and it has enough processor capability. And then this is kind of the standard Werover pinout, the module. So when there's an ESP32S3, which is like the dual core version of the S2, we can drop that in. Only downside is there's not going to be as much storage space because we're using the built-in 4 megabytes of flash. What I have to do is actually contact Espressif and see if they'll make me a 16 megabyte version of the Werover. I would spend a little bit more for that. But otherwise, otherwise it's the same exact, layout for everything. Same pinout down here, Stemma QT, Stemma matrix here, level shifting, and then of course the Wi-Fi. So, it's something that I've been meaning to do. When I designed the matrix portal, the ESP32S2 was not out yet, so we couldn't use it. But I like that now. There's some of these designs people are like, oh, are you forced to redesign? It's like, well, I was going to do it anyways. Now I just kind of have that little bit of the push. I'm also going to redo the Pi portal as well to use the ESP32S2. So that's, this is the redesign story. So things are going to be a little bit weird. There's going to be like stuff not coming out. Like it's, I designed a couple boards and like I can't get chips, and some of that can get chips. So it's like, all I can recommend is constantly be looking. Don't just because you don't see something and it's like they won't be in stock, keep looking. Sometimes things, pop up. Okay, so speaking of designs that I'm getting back into, let's go to the overhead. And so one design that I had to, overhead's really dark.
Void.
I know, no, it's because it was so bright. One design that I took a break on was, if people remember, I designed this SCD41. Sorry, 1 second. You can do it, little thing. Okay, this SCD41. This is a CO2 humidity and temperature sensor. People love the SCD30, which is a really great NDIR CO2 sensor. Very popular because people are doing a lot of CO2 sensing for, COVID air quality. They're trying to prevent the passing of viral particles by increasing air quality, and CO2 is a really good mimic of that. It's it helps if there's enough airflow because you want to get it down to about 400 ppm. I designed this, I was really psyched, ready to ship it, and then of course I couldn't get sensors. But then I suddenly they're available again, so I picked some up, and so this design is going to go out the door.
Just on a note though, just get some of the Espressif stuff.
Yes.
I saw that Espressif is going to be launching a Zigbee ESP. It's an ESP32H2 based on the Git commits. It's a 96 megahertz RISC-V core with a 802.15.14 Zigbee radio, BLE, no Wi-Fi, with a 4045 GPO.
Oh, cool.
And someone spotted that because of the GitHub commits.
Eagle eyes, I know. Subscribe to people's GitHub atoms. You never know what. RSS is still one of the best investigators.
No, this wasn't it. This was Matt Metz, who I happen to know, posted it up on Twitter. So I'm going to put that in the Discord chat.
Cool. I know, secret. Well, I'll say something. Espressif there. They're secretive, but they're not that secretive. Like they do betas and they get people involved, but it's not. Look, if you have a 2.4 gigahertz radio and you've been able to tack that on to your chip, of course, Wi-Fi, of course, Bluetooth, and of course Zigbee. All of these are 2.4 gigahertz.
Anyways,
makes sense.
So I put links on that.
Cool.
It might disappear later.
One thing I did that's interesting with the SCD40 is this. Module can run from 3 to 5 volts, but I still stuck a voltage regulator on it. Why? When you can run it off 3 or 5 volts. Well, first off, this is kind of an expensive sensor. You really don't want to blow this up by accident. Having a regulator is just another little level of protection in case this is very sensitive to voltage spikes. If you accidentally plug it to VIN on an Arduino, it's 9 volts. You'll be fine. Another thing is it's very sensitive to ripples in the power supply. The data sheet sort of says, please keep the ripple under 20, 30 millivolts. And a low dropout regulator will really help with that. You power this from, not necessarily the quietest power supply, but the highest power supply. So on Arduino, the 3 volt power supply actually may not, be a good choice for this. It might not be able to handle the current requirements, but if you plug into 5 volts and then regulate it down to 3, you might be good to go. I don't know, whatever. I'm putting some jumpers on the back if you don't want that. And then another Stemma QT design that I'm wrapping up, and this one is just hella bright, is, I think we chatted about this, is the IS31FL3741. This is an RGB, this is the chip here, it's an RGB LED driver. So these are bare LEDs, and you'll notice, I hand soldered these, so there's just kind of missing one row, and this LED doesn't have all the pins, and this one didn't make it at all. I just kind of didn't feel because if the grid in general works, I know it's working fine because this is a grid matrix layout. The pick and place will do a much better job than my hand tweezing. If you really like watching people hand tweeze small RGB LEDs, check out Greg DeVille's social media. He's definitely a beast. He'll do thousands. I'm much lazier. I have a machine. I want the machine to do it. I just want to get this prototype done enough that I can hand it off to the pick and place. So it looks good. So just doing a little RGB test with this. And this is, we chatted about this a while ago. If you want to make a breakout with a lot of RGB LEDs, after 10 or 20, it flips over to being a better idea to use a LED driver and raw LED chips, which we covered on the Great Search, than NeoPixels or dot stars, because NeoPixels and dot stars are quite expensive individually compared to bare RGB LEDs, which are a penny or two a piece. So that's what I've been working on. So if there's any questions, or we'll go into the Great Search.
What's the name of the LED driver?
This is the IS31FL3741.
All right, Skir placed 450 NeoPixels on Friday. Total of 500 last week.
Who did?
Skir.
Okay.
In the chat a lot.
Yeah.
All tweezed.
Yeah, these were, once it's first, I can rework some of these, but eventually I'm just what?
On one hand, it's therapeutic. On the other hand, just be careful. Because, that's a lot.
I find my eyes get a little twitchy if I do too many. I just want to get this up and running again. The pick and place will do an excellent job at this. Much better than mine. I have no problem tweezing, believe me. I tweeze.
I think it's soothing, but you might not be able to do it long term.
This is what, 13 by 9 LEDs? So what's that?
Yeah.
100.
Oh, wow. Someone placed 1,100 805 LEDs a day before, and they were using a vacuum pickup tool. Y'all are committed.
I like how we've discovered a thing, which is the LED placement, the LED placement crew.
Someone kind of said the same thing I always wonder. The new RISC-V chip from Espresso is so nice. I hope it has native USB so it'll work with CircuitPython. Me too. And I know it doesn't.
It doesn't. It has a weird, not weird, but a special debug only USB. It's not a true native USB. But I think they will eventually. I would love to see a native USB RISC-V.
We'll get there.
Because I think it would be great for Arduino or CircuitPython.
I think one of the things that's going to hold back RISC-V is the USB support, but once they do it, there'll be a menagerie of boards that come out.
I would, as soon as RISC-V uses USB, we'll have TinyUSB. I guarantee you we'll have TinyUSB for it. And then once there's TinyUSB, it makes it easier to do Arduino, it makes it easier to do CircuitPython.
We even joined the RISC-V coalition, and I thought that would be a track in, but it wasn't. I tried.
Okay.
All right. Is it great search time?
It's time for the great search.
Where in the world is that part I need? The great search with DigiKey.
All right. The great search is brought to you by DigiKey. Thank you, DigiKey. And Adafruit. Ladyada uses her skills of an engineer to navigate the DigiKey site to find the things that you're looking for. More so than ever, that's the most important thing because planet Earth ran out of parts.
I know. We have a lot of sand, but we don't have any silicon.
So what's the great search this week?
Okay, this week's great search. So one of the nice things about the great search is what I do is during the week when I'm struggling with finding a part, because every week there's a part that I can't get, and me and the purchasing team, we use our wits to find alternative parts, which is an engineering skill. Speccing the parts one thing, but then being able to find alternative spec parts is important also. It's really easy to get the exact same component every time, but eventually that component is not available, and that's happening a lot. So let's talk today about one of the most jellybean components we use, which is the BSS 138 dual.
Can you say what jellybean is for the folks who aren't in this industry?
Jellybean, I don't know where this came from. I picked it up from someone, but jellybean means it's a part that's so common that it's made by multiple places, like a 7805 linear regulator, right? Very, very common, made by multiple companies. It's well spec'd. It's not a unique part, like I was showing off the IS31FL3741. That's a very specific chip.
If anyone knows why it's called jellybean, put in the chat. Because this week coming up, LeVar Burton's hosting Jeopardy, and I know this is going to be a question.
It's totally been a question. Electronic component history.
Yeah, but if you know why it's called jellybean or the origins of it, no Googling allowed, because I can Google later. But that I've heard this too.
Yeah.
And I heard Bunny say it to me like, I don't know.
I think I picked it up from Bunny.
I heard it from Bunny like 15 years ago. Yeah. So I have a feeling this is an older industry term. But anyways, it'll probably be the final Jeopardy question.
Or jelly beans. Basically, it's the things that you sprinkle that are not... there's the Wi-Fi chip, the Bluetooth chip, the espresso chip. This is like, there's only one place to get it. And then there's jelly beans. Okay, so the jelly bean part we're talking about today is the dual BSS 138 N-channel MOSFET. So this part, as shown here, we use tens and tens of thousands, like 100,000 a year easily, because they go onto every one of our breakout as level shifters. We use them to level shift I2C, pull-ups on either side. Why do we do level shifting I2C? Because when we sell sensors, a lot of sensors, like 99.9999% of sensors and devices are 3.3 volt logic and power. Although, we do have a couple 1.8 volt ones as well, which is important. We'll actually chat about that. And I want to make sure that people can plug in their boards into an Arduino Uno or a Mega or a Zero or, an ESP32. You don't know if it's going to be 5 volt or 3 volt on the other side. And we want to shift the I2C logic, and nothing beats the simplicity and price of this. 2 N-channel FETs, 4 pull-up resistors, and you're golden. In fact, this is NXP in their kind of famous I2C level shifting techniques in bus design. So it's like a tome, a famous work. They show this off and they talk about it. And then the shows, this is basically what's going on. You have I2C on either side, and this does a great job. And this is a rock solid design. I mean, I've used this hundreds of times.
I have some breaking news.
Oh, what?
Jellybean dates from the early days of Intel and Fairchild Semiconductor, referring to common chips. Gordon Moore may have coined the term jellybeans.
If it's not true, you've totally tricked me.
Well, if we're going to start misinformation, let's just start with
this. This is way better than most.
Right? Let's do this.
So the BSS 138, I've really liked it, and I've used it before. It's kind of famous. People use it a lot. And I like the dual FET because, you need 2. So why not just have it in 2? So this is the hold on. Let's go like that. This is the piece. It's a SOT 363. It's small, it's easy to pick in place, you can hand solder it, it does the job, it's great. Except when you cannot get any. So I was on DigiKey earlier this week because we're like, okay, we need more BSS 138 duals, and so I'll just show, when you go to, they have some exact matches, but we want the array because we want the dual. And then if you look, 0, all out of stock. And like, I have never seen this in my life. There's always like a million of these in stock. Because again, they're so jellybean, they're used everywhere. Time to freak out and give up? No. Time to use our great searching power to find an alternative. And note that this is a jellybean, the BSS, you see it's made by MCC and diodes and Nexperia. This is one situation where not only is I tend to buy the Nexperia part, but all the alternative sources for the jellybean are also out, right? So it's not like, just find it from another maker. We actually have to find something that has a different part number but the same functionality. So let's, I like to use the product attributes as a way to pick out which ones to get. So let's go with active, dual, and channel. I'm not going to necessarily pick the logic level gate. The drain to source voltage, actually, it's 60. You don't need that much, right? Obviously, we're not dealing with more than a couple volts. I don't want to be specific about the RDS on or the current drain because, again, it's a little flexible with that. But I am really picky that I want it to be surface mount and I want it to be SOT 363 because I need it to be drop-in replacement. So let's view similar. And you get about 118 options. Since I really need to, I need to have this in stock, I'm just going to pick in stock immediately to pare down the options. So the next question is, like, what of all of these things are important? Well, RDS on is something that you care about when you're dealing with like a power transistor, when you have a lot of current passing through, because the RDS on determines the voltage drop across the drain and source. In this case, it's logic level shifting. So I wish I could actually hide, this and say, like, I don't even want to look at this option. I don't care about that. Also, current. There's almost no current passing through here. This is a logic level. This is, milliamp maybe when it gets pulled down. Almost nothing. So, power max, the temperature, a lot of these things are actually not important, but there is one thing that is important, which is the VGS. Why? Because when you look at here, this voltage, especially for the low voltage, you used to be able to turn this on and off based on the lowest voltage that you will encounter on the bus. So if you're doing 3 volt to 5 volt, you just have to make sure that the VGS is, greater than 3 volts because you just want to make sure you turn it on and off. I like to have it a little bit lower than just on the edge, even though it's the max, in case your power supply droops and it's not exactly 3.3 and it's 3. So you want it to have a little bit lower, so maybe 2.6 volts. However, we use these transistors also to logic level shift 1.8 volts, like the SGP30 gas sensor, and a couple other sensors we use are 1.8 volt. We have 2.6 volt logic. There's a couple, not a lot, but enough that I want to make sure that I don't mess things up for them. Because believe me, I have accidentally placed a 2N7002 dual FET, and it did not work on low voltage level shifting. I think it was a 7002. I don't remember the exact part number, but basically it didn't have a low enough VGS. The turn on voltage was too high. It didn't turn on and off. So what you want to do is make sure it doesn't, the BSS 138, let me go back to DigiKey. One moment, let me look up the part number.
Yeah, we get to the point when we show stuff on Desk of Ladyada, we make sure we purchase it before we talk about it.
Yeah, I bought. Yeah. You'll see, like, why are you showing this off? There's only 5,000 stock. Yeah, because I already bought like 50,000.
We learned our lesson.
I learned my lesson.
Mistakes were made. Lessons were learned. It's a new segment, so we're not doing it this week because
it's unboxing.
It's AdaBox, but the new segment is called "Mistakes Were Made, Lessons Are Learned." So this will help all of you out there thinking you need to be perfect. You don't. Just be honest.
Okay, so this what I liked about the BSS 138 is it has this VGS you see here, 1.6 volts. You don't have to be exactly 1.6, but you want it less than 1.8, and a little bit less than 1.8. And you'll notice that actually there's nothing here that's exactly 1.6. That's why you don't want to be. I didn't click that off because it's like it just can't be larger than 1.6. So let's select everything less than that. And, you know, I don't really care about the VDS or nothing here. And nothing else here is that important, to be honest. And then when you go down here, we actually have a couple options. Again, you know, these are all in stock. You'll note that none of them have hundreds of thousands in stock because I kind of purchased a bunch of them. But they all have the same package. And here's the good news. All these have the same pinout. The dual FET pinout is a standard pinout. Like they are symmetric and equivalent. So yes, I'll check the data sheet, but you can, in this case, just trust me. I already looked it up. So what I did was, you know, I only really care about price in this case because, you know, the specifications are that important. And so I actually found the alternative, which was an NX138, which is actually, I like the look of that, right? A BSS 138, and this is the NX 138. This is kind of I have a good feeling about it. It matches the specs, but I also like it when they reuse the part numbers. It's a little bit of a hint, kind of telling you, like, this is going to be similar as a drop-in replacement. So this is the part. So this is, you know, there's still some in stock. I didn't buy them all. Did buy a couple. So that we can keep making our breakouts because it's you know, I really need to have a dual FET. Every single one of our breakouts, every one of our Stemma QT boards.
Right. So they do have a question about it, and since there are pull-up resistrons on the board, I assume I don't need to add them.
You don't. We put very weak pull-ups, 10K, which is good for, you know, 100 kilohertz I2C. If you want to run 1 megahertz, I would recommend adding another one. But 10K is a nice balance of, you're not going to hang your I2C bus. It'll run at 100 kilohertz or 400 kilohertz, which is like kind of, you know, what most default buses run at. But also if you put multiple of them in parallel, you know, because you plug in I2C, multiple QT boards, you can plug, you know, up to 5 of them, and then you'll still only have a 2K pull-up. You know, that's what it'll look like to the host, which is the standard pull-up size. So what I like is you can put like 5 to 10, and the host won't get overburdened by the pull-up. So I like 10K. I'm like a 10K kind of girl.
All right. Someone has, I think this might be a future great search, or it's a general question.
Yeah.
Not quite sure. It says, how to choose piezoelectric actuators for replacement parts for in-body image-stabilized cameras.
Oh, goodness. Those are going to be really custom.
Yeah.
I really think what you should do is try to... I would actually go on eBay, to be honest, and see if you can find people selling.
Yeah, and there's also
broken.
camera repair. I think that's in the camera repair category where it's like...
It's a different thing, but you want to find people who are throwing away cameras with like broken lenses or broken main boards, and then you can maybe recycle the piezo actuator.
Yeah.
But like, that's going to be
I feel like
really,
there's an industry around this that I don't know about.
It's custom. Anything piezo is super custom.
All
right, so that's the great search. Thanks, everybody.
Where in the world is that part I need? The great search with DigiKey.
All right, and I think that is it.
Okay.
Just a little bit of a programming note. We just sent, so all the ADA boxes are getting processed to ship. So if you have one, well, if you have one, don't tell anyone what it is. But if you ordered one, we're wrapping up the last few.
We still have 1,000 to ship. We're getting through them. Believe me, it's been a journey.
Yeah. You can, I mean, like, you know, don't spoil it, but you could figure out what's in this ADA box. And
look, I don't try to. It's not super secret.
I mean, like this is kind of geared for kids too. Yeah. But if you want, you can still sign up for ADA box like this second, because we're about to close any shipments soon.
Yeah.
So this might be the last.
We are wrapping up early next week.
Yeah.
We're like Monday or
so
Tuesday.
You know, if you look around and you want to figure out what it is, you can. And then you can still get one, like right now. Like if you order one today, you would it'd be shipping by the end of the week. So that's kind of a big deal. Other question that came up, or a request, would love to see a 4 to 2 milliamps with maybe a 16 volt source and a Stemma connector.
Yeah, I haven't done a lot of 4 to 20. I gotta look into that stuff.
Okay.
About it.
Someone already got their ADA box, and them and their daughter assembled it. Okay.
Aww.
That's good. And someone who lives close to New York, sorry, you're the last one to...
We actually do a little... It's not 100%, but we try to ship the ones that are farthest
Yeah,
first.
because it's UPS ground.
So that
US,
if you're on the opposite side of the country, yours...
Yeah.
It's not 100%, but we try. So that... Because if you're close to us, you're going to get it the next day. And so we want to kind of try to... We're trying to make it so it's like if you're the last person shipped and you're all the way across the country, it takes another week. So that's,
All right.
Math.
And that
all right, thanks, everybody.
is Jessica Ladyada. Bye, folks.
Have a great week.